Hello, in this section I will go over L'Hopital's rule and how to apply the rule. So let's talk about L'Hopital rule. The textbook definition is this. I'm just going to say it. I'm going to read it. Let f and g be functions that are differentiable on the open interval from a to b, containing c except possible at c itself. Assume that g prime of x does not equal 0 for all x in a to b except possibly at c itself. So if the limit of f of x over g of x as x approaches c produces the indeterminate form of 0, 0, then limit of x approaches c of f of x over g of x equals limit as x approaches c f prime of x over g prime of x, provided that the limit on the right exists or is infinite. This result also applies if the limit of f of x over g of x as x approaches c produces any of the indeterminate form of, if so, positive infinity over positive infinity, negative infinity over positive infinity, negative infinity over negative infinity, and positive 0 over 0. So what does that mean? What does that mean in so if you have a limit as x approaches c of f of x over g of x, then the limit of x approaches c, and when you put in c into the limit, and then your limit either becomes infinity over infinity, negative infinity over positive infinity, positive infinity over negative infinity, negative infinity over negative infinity, or 0, 0, you can do this. You could take the derivative of the numerator and then the derivative of the denominator until you don't get any of these forms. So you may have to take the derivative more than once. Usually it's just once. So let's do example 1. So what is the limit as x approaches 0 of e to the 2x minus 1 all over x? So let's see what happens when you plug in 0 into the function. So that would be e, and then 2 times 0 is 0, minus 1 all over 0, right? And e to the 0 is 1 minus 1 over 0, which is 0 over 0. So it's one of our indeterminate forms, right? We can't have 0, 0, 0 over 0. So what we're going to do is take the derivative of the numerator and the derivative of the denominator. So it's going to be limit okay. So yeah, let's take the so it's going to be so what is the derivative of the numerator? The derivative of e to the 2x is just going to be 2e to the 2e to the x. So I mean 2x, sorry. It's so you take, yeah, so it's 2e to the 2x, and then the derivative of x is 1. So when you put the limit as x approaches 0, it's going to be 2e, and then 2 times 0 is 0 over 1. And e to the 0 is 1, so that's 2 over 1. So now, as you can see, it's not in indeterminate form, it's just 2. Let's do example 2. What is the limit as x approaches to infinity of ln of x over x? So let's see if we plug in infinity. This would be ln of infinity over infinity. So what is the ln of infinity? It's actually going to be infinity. And then on the bottom is infinity. So it is in indeterminate form. It's infinity over infinity. So we're going to have to apply L'Hopital's rule. So you just take the derivative of the numerator, so the derivative of ln of x over x prime. So that would be, what is the derivative of ln of x? It is 1 over x. And then what is the derivative of x prime? It's just 1. You have a complex fraction, so you can rewrite this as 1 over x divided by 1. And when you cross multiply, it would be 1 over x. So what's the limit as x approaches to infinity? And then it's just going to be 1 over x. And then when you plug in infinity to the x, it'd be 1 over infinity. And what is 1 over a very large number? It's always going to be 0. Okay, let's do example 3. So what's the limit as x approaches to negative infinity of x squared over e to the negative x? So what happens when we put negative infinity? This would be negative infinity square e, and then it's minus a minus infinity. So that would be positive infinity over positive. So this negatives becomes positive. So what's e to a very large number? Infinity, right? It just becomes positive infinity. So we have indeterminate form. So we have to take the derivative. Let's do that. So you don't apply the quotient rule. You just take the derivative of the numerator and the denominator. So it's going to be x squared prime over e to the negative x prime. Okay, so x squared prime is just 2x. And then e to the negative x is the derivative of e to the negative x is negative 1, e to the negative x. So when you put limit as x approaches to negative infinity, it's going to be yeah, what happens? Would it so it's going to be 2 to negative infinity over negative 1 e to the minus a minus infinity. So 2 times a negative infinity is still going to be negative infinity. And then over here, this is going to be e to the positive infinity is a very large number times by negative 1. That's just going to be negative infinity. So you still have indeterminate form, so you're going to have to take the derivative again. So the limit of x approaches to negative infinity of not x squared, but 2x. So it's going to be derivative of 2x on the numerator, and then on the bottom, it's going to be negative 1 e to the negative x derivative. And then the derivative of 2x is 2, and then this would be e to the negative x. So what is the limit of that? So the limit as x approaches to negative infinity of 2 over e to the negative x. That's going to be 2 over e and then minus a minus infinity. So 2 negatives becomes a positive. So it's really saying 2 e to the infinity or e to a very large number is going to be positive infinity. And then 2 over a very large number is going to be 0. Okay, let's do example 4. We have limit as x approaches to negative infinity times it by square root of x. So if you put infinity immediately, you're going to get a 0 times infinity, right? Because e to the negative infinity is going to be 0, and then radical to infinity square root of infinity is infinity. So what I would do is rewrite this as using only positive powers. So e to the negative x is the same thing as 1 over e to the x. So we could put that in the bottom. And then on the top is just radical x. And then when you put in infinity, that's going to be infinity over infinity. So it is indeterminate form. So now we can take the derivative of the numerator. So it's going to end the denominator. So it would be x to infinity. Radical x is the same thing as x to the 1/2 prime. And then e to the x is prime. So what's x to the 1/2 prime? That's going to be 1 over 2 radical x. And then what's e to the x prime? It's just e to the x. So this is going to be 1 over 2 radical x divided by e to the x over 1. Cross multiply, so that's going to be 1 over 2 radical x, and then it's going to be e to the x. So it's going to be limit as x goes to infinity of 1 over 2 radical x times e to the x. So when you put that infinity, it's going to be 1 over 2 radical infinity e to infinity. And then on the bottom, it's just going to be 1 over infinity. And 1 over infinity is going to be 1 over a large number is always going to be 0. Last example. Let's say we had limit as x approaches 0 of sine of x over x. So when you put it in, when you put in 0, you're going to get an indeterminate form. Oops, yeah, this is not, sorry, this is 0, not infinity. So this would be 0. So sine of 0 is 0 over 0. So you have indeterminate. So we do have to apply the L'Hopital rule. So it's going to be limit. So the derivative of sine of x, so the derivative of sine of x is cosine of x. The derivative of x prime is 1. And then when you plug in 0, cosine of 0 over 1. So cosine of 0 is 1 over 1, which is 1. So that is your final answer. Thank you. Have a good day. Bye-bye.